Welcome back. Today we're doing 105 construct binary tree from preorder and in-order traversal. Now these may be new to you, but trust me, once you learn it, you will feel confident with a little bit of practice. Now, given two integer arrays, preorder and in-order, where preorder is the preorder traversal of a binary tree and in-order is the in-order traversal of the same tree, construct and return the binary tree. Okay, so let's go through the example and we'll figure out what these are. Now in this example, there's a 3 root. To the left of it is a 9. To the right of it is a 20. So 3 left, um, that's a right 9, 20, right? And to the left of the 20 is this 15, and to the right of it is this 7. Now what is preorder? Preorder means that in the traversal, you are addressing the node first, and then the left, and then the right. Okay, so let's do preorder here. Now, what is the node? Well, the node is, I'm going to make this yellow so it's very apparent. The node is this one, right? So the node is the 3. Okay. Now that we've processed preorder, we can go left if needed, go right if needed, right? So we go left, right? Let's move that little arrow here. And what do we have here in the left? We have a 9. Okay. And is this the full traversal of the left? Well, like if this was a, let's say this was a box, couldn't see anything in the box, right? Is this a full traversal of the left? It is, right? Now we want to do a full traversal of the right. Now what's a full traversal of the right? Let's pass this down, and we're going to continue recursively a preorder. Now what does preorder mean here? Let's preorder ordering is the root, the left for a certain amount. There could be no left, right? But it's left for a certain amount, and right for a certain amount. Okay? So let's just make it green here, red here, and I'll make this yellow. So preorder is root, left, right. Okay, so let's say you're given the 20 and you're still doing preorder. Well, what does that mean? Well, the preorder is that 20, and then you go left, and that's the 15, and then you go right, and that's the 7, right? That's what we have here. Here's the preorder. So it's 3, 9, 20, 15, 7. Okay, so what do we know about this preorder? We know that it is root, left for a certain amount, right for a certain amount. Now, if we're just looking at the preorder, we know exactly what's the root. We don't really know which one is left, right? It could be any one of these. We don't know which one is right, right? It could be any one of these. So what we do know is that left is a certain length. It could be 0. It could be, all of it. And of these, there's some type of point here that splits them, right? Some type of index where either everything is right, or it's somewhere in the middle, or everything is left, right? There's something that splits these because left is a certain length, right? So let's just say length question mark, length question mark. Okay, so that's preorder. Information that we have for sure is which one is the root. So what is in order? Okay, let's look at in order. In their example, in order is 9, 3, 15, 20, and 7. So in order is a little bit different, right? So in order is, instead of going root first, right, that's not the thing that we're guaranteed. I'm going to group these. Given a node, I'm actually going to traverse left first, right? Whatever is on the left, I'm going to traverse that amount. Then I'm going to traverse the root, and then I'm going to traverse whatever's on the right, right? So using this example, given a 3, what would you think is the first value of an in order? Well, traversing left first, right? I'm going to call this on this node with the 9, and because this node with the 9 has nothing to its left, it has nothing to its right, Well, it's going to process its own left, which is, none. It's going to process itself. It's going to process whatever's to the right of it. Okay, so what does it mean to process left? Well, none is none. So the first item here will actually be this 9. Okay, so it passes it back up to the 3. Next item is a 3. Passes this down to the 20. Now 20 has the same condition, right? It's going to pass in order, so it's going to process whatever's to its left, that 15, and then process itself, 20, and then process to the right, 7. Okay, so what do we know about preorder in the same rules, I guess, right? Or the same sections. So Inorder has left, right, dot, 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 at some amount, and then it has whatever's its root, right? So let's say it's the 3 here, and then it has right to a certain amount, okay? So it's basically here. I'll even use the same colors. It's basically these, but a little adjusted in ordering. Okay, it has some amount left. We don't know what length. It definitely has a root, and then it has some amount right. Right, that's the in order. Okay, so one thing we know for sure for preorder is where the root is. One thing we know for sure in order is that if we did have the same root, let's say these 3's are aligned somehow, right? If we did have the same root, actually everything to the right of that root should be that right side. Everything to the left of the root should be that left side. Right, so we do know that. And what does that allow us to know? Well, if we know that everything to the left and the right are these positions, then we actually know the length. The length is not a question mark. Right, we can go ahead and delete these question marks. Because given this value, well, we can just count the length, right? The length here is, there's only a single 9 here. Length is 1. There's 3 elements here. The length is 3. Right? So we have 1 and 3 here. And Inorder and Preorder are referring to the same tree. So we actually know that if this is of length 1, let's say left, then in the Preorder, if we just look one index, then this is the left. And if this is of length 3, right here, then we know that if we look in Preorder and we look at the 3 here, then, well, this is the right index. And that's a really big deal, right? Because let's say we are responsible for producing the tree, right? Let's put the tree aside here. Well, if we're responsible for producing the tree, we can use this information. Now, what are we going to use? Given preorder, given Inorder, what do we know, right? In fact, I'll write this anew just so you can see that we can come up with this. Right, so given preorder here, given Inorder here, what do we know? Well, we know, first off, this is the root. That's what we know, right? We know that something here is left and something here is right. We're not sure. We know that if we do find this root, this is left and this is right. Right? Taking the same lengths, we know that this becomes left, this becomes right. Importantly, though, we know that this is the root. Knowing that this is root, we know what should go left and what should go right. And let's think about it. What should go left? Well, going left could actually mean using the same structure of data we have here, but sliced a little bit. Okay? So, what's being used for the root node? This preorder and this Inorder. Okay? What should we pass going left? Well, we know that this is left. We know that this is right. We know that this is root. So actually, we should pass a sliced version of these, right? And what type of sliced version? Well, we should pass this, right? To the right, we pass this right, and to the left, we pass this left, right? And this is what we're going to use to create these nodes. Now that we've passed this left, what do we know about these nodes? These aren't left and right anymore. They are their own separate ideas. We know that the first item in preorder is root. So we create a 9 here. Right? We know the first item in preorder here is root. We can create a 20 here. Right? What does that mean? That means that this has its own left. It has its own right. Right? This 20 designates these as its left and these as its right. Okay? So we can go left, we can go right. And what are we going to delete here? Here we're going to use green as left, right? And here we're going to use red as right. And these are standalone. They're nobody's left, they're nobody's right. They're standalone. And we know that this is a root and this is a root, right? So this returns a 15 and this returns a 7. And what's here actually? Maybe we should answer this as well. What happens when you have essentially an empty array here and an empty array here? Well, because this is a tree, these can actually just return none, right? Returning none makes these leaves, right? Not so pretty, but let's see if I can smash them together and get a better diagram here. And this is the main idea, right? The fact that we're taking the full preorder, the full inorder, using that to generate the current node, and creating slices of them to pass to the left, and a slice of them to pass to the right. Okay? And that's what we're going to do here. So we're going to build this tree, right? To make it easier, I'm going to make a go function here. We're going to call this go function, and we're going to return, well, we might return whatever comes out of this go function, actually. Right, and what are we passing into the go function? We want to pass in the preorder, and we want to pass in the inorder. That's as much information as we have, right? So the preorder here is the remaining preorder. Now, we might want to use a different variable name if it's confusing. I could put an R here, remaining preorder, remaining inorder, right? And let's just deal with the edge case first. So if the length of this is 0, let's just return none. Okay, so that's these cases right here, right? These are the leaf cases, and it's not just both, right? You could have, let's say, a node that has a left side but not a right side. You could have a node that has a right side but not a left side, right? So if the lengths of these is 0, then return none. And these lengths, preorder and inorder, should be the same length, right? They should never differ. If you want, you can put an assert here, and it's not going to help you in Leetcode, but just to ensure that this never happens, you can put that in there. Okay, so what is the root? Well, the root value is the first value in preorder, right? It's, for this example, it's the top example right here. I'm going to make a big arrow so we know what we're looking at. I'll make that blue. Do I have anything blue? No. So for this example, right, it should be the 3. So the root value is a 3, and I'm going to create a tree node with that root value, right? Val equals root val, right? This is going to be a new node. And what I want to do is essentially return this new node, but I want to populate left, and I also want to populate right, right? So I'm creating a node, right? Create a node. Let's say this is a step, right? Create a node. This is a step. Populate left is a step. Populate right is another step. And another step is returning that node, right? So what does populate left mean? So I want to get the elements that are to the left, okay? So what does that mean? Well, I have this root value, and I have the benefit here. Do I have the benefit? Let's see. Where preorder and inorder consist of unique values, right? So what I need is to find the index of this 3 inside of this inorder, right? And I can do that with just looking at the index, right? So index of root val is looking at inorder, right? This is actually the inorder index of root val, right? Looking at inorder and getting the index of root val, right? So here's what I know, that everything to the left of that index is left, everything to the right of that index is right. Okay. So what is the new? Let's say what is the inorder and the preorders that should go on the left and the right, right? So the left preorder, the left inorder, and then I'm going to do the same where I'm going to get a right preorder and a right inorder, right? So what is the left? Let's do the inorder because the inorder is the easiest, right? So the inorder is the existing inorder, right? The remaining inorder. Probably should not have put that R. Can I afford to delete it? I think I can. It's just a little annoying. I'm going to delete this R. It doesn't help. It doesn't help anything. I can go ahead and mutate it. Okay, perfect. Just for to make it a little neater for me. So inorder, I'm going to slice it, right? And where am I going to slice it to? I'm going to slice it from 0, and you know, if it's 0, I can skip it. I'm going to put this colon here. I'm going to go up to this inorder index of root val. Now, importantly, I need to go up to. So let's say this is a let's say this is index 1, right? So this preorder is this 3. Here is index 1. This is going to go from 0 to 1. Is that right? Is it 0 to 1? 1 is exclusive. So this should capture the 0. If I go this way, 20 is here. It's going to be 1. And this should capture the 0. Yeah, I think it's right. Okay. Now, what do I do with the preorder? With the preorder, I have the root, and I need to know how many of left exists, right? So I know that based on the index. Let me actually just use an example so it becomes super clear. So the index of this 3 becomes 1, right? So if in order, I need to slice here to 1. So I want this slice. So the left in order. For the right in order, I need to slice that 1, but I don't want to be um, inclusive of the 1. I want to slice that 1 plus 1, so it's actually 2 onwards, right? So that's left and that's right. So I'm going to go ahead and go right in order is the in order, and I'm slicing from the in order index of root val plus 1 onwards, right? So that's these two sides, right? So how does that help me get the preorder? So for the preorder, I need to start from, so this is guaranteed to be index 0. So the preorder, I need to go from 1 towards the length, basically, of this, right? The length of this slice. So if it was, but it actually needs to be the length of the slice plus 1, because I need to go from 1, let's say the length of the slice is 1 here, right? 1. I need to go from here to 2, right? So it's length plus 1. So the length preorder should be the preorder from 1 to the length of the left in order. That sounds about right, I guess. So it's that's this one right here. That's this 9. And I need to go to the rest of it, which will be that value continued on. So it's going to be the preorder, and it's going to be the length of that left in order onwards. Okay, so let's run this one time. We're not going to do anything recursive yet. Let's run this one time and let's double check. Okay, so what do I need here? Let's print the index. And let's print the root val, I guess. Let's print the left in order, the left preorder, let's print the same for the right. Okay, we're doing nothing recursive yet. We just want to see if these are the right values. Okay, so we have a 3 here, and the left in order correctly has this 9. The left preorder does not. Why would the left preorder not have it? Oh, because I forgot to do the plus 1. So the left preorder needs the plus 1. This one also needs the plus 1. Right, so the right preorder should not have this 9. It has to do, we have to have the plus 1. Okay, great. So our left in order and preorder have the 9, has the 9 here. And let's look at our right preorder and right in order. And does it match what we have here? The 20, the 15, the 7. Okay, so the in order is the 15, the 20, and the 7. That's this right here. And the preorder has the 15, or the 10, the 20, the 15, and the 7. It's that right there. Okay. Let's delete some of the stuff we have here, because it got a little messy. Okay, perfect. Now, we want the right value of this new node, right? And the left value of this new node. To recursively call the values we're creating here, right? Where we have a left preorder, a left in order. We have a right preorder, a right in order, and that's going to be responsible for setting these arrows, right? These arrows right here, where this is the dot left, this is the dot right. Okay, so let's print new node here, and we should be able to see it. Okay, so we have the 3, right? On the left side, it's going to get this 9 and this 9. On the right side, it's going to get these values. So here we're processing the 9, right? The 9 on the left side gets nothing. On the right side, it gets nothing as well, right? So here it's going to return none. And this is what the 9 looks like, right? It's a node that has a left none, right none. What does it look like when we process the 20? Well, the left side is going to get this 15, right? That's exactly what we have in this drawing right here. And the right side is going to get the 7, right? That's exactly what we're going to have in this drawing right here. What's going to happen when we process the 15? Well, the left is going to have nothing. The right's going to have nothing. And it's going to return upwards this tree node. It's a 15 with the left as a none. The right has a none. 7 does the same thing. It returns the same thing. Now, what does 20 actually return? 20 returns itself with the left pointing to this node, right? It's created here. And the right pointing to this node that's created here. What does 3 return? 3 returns the same thing. Itself plus a left that was built and a right that was built, right? With that subset that we created using these colors. This gold, this green, and this red. Okay, so test pass, and let's submit it. There might be an edge case that we should consider here. What if these are empty at the start? These are empty at the start. Do we want to just return none? I guess we do. What if these are... they're too large. What if they are too large? Time limit exceeded. It looks like printing this. It looks like printing this slows it down a lot. Don't want to be printing this. Let's try this without printing it. See if the test cases pass. And really, oh, I'm still printing it. I'm printing a new node here. The test cases don't matter as much as ensuring that you understand it, right? Because right now you're trying to learn it, and you're trying to figure out the pattern here in preorder, in order. What does it mean? What guarantees does it give us, right? The preorder, the guarantees that it gives us is that we know the root. We don't know what left is. We don't know what right is. We know that it could be a left, it could be a right. In order is where we learn, if we're given the root node value, what is left, what is right. Now we know if there is a left, there is a right. We can use that information to look at preorder and say, well, these go left and these go right. And for those 2 nodes, when it's recursive, this idea of a root, when we pass it to the left, well, if this is a left, that becomes that root, right? And we pass it to the right, that becomes the root for the right. And then when 20 passes, right, because we have this, when 20 goes left and 20 goes right, well, that's going to have its own preorder, and that's going to be its own root, right, for the left, and that's going to be its own root for the right. And if there were any more, Well, this would get smaller, and this would be another root somewhere, and then that would be some root for the left and the right, and then if there was another one, that would get, become smaller, and then become another, and it would keep going on. So preorder gives us the ability to distinguish root. Inorder gives us the ability to find the length of the left and the right, put them together, and now we have been able to decode the entire tree. Thank you so much. Leave any comment if you want me to answer any question you want. I'm just going in order right now, week 6. Next week, week 7, we will do container with most water. Any questions, leave a comment and I will answer it. See you on the next one.